You are trying to push a heavy box across the floor. It's causing you some trouble because the floor is not very smooth. Sketch a free body diagram of the box. So this will often happen when you're moving a fridge. So we have our box or our fridge. It's on a surface. That surface is going to be the floor. Okay, so we have this force of gravity and we have that normal force. Those should be exactly the same size. Okay, we're trying to push it. So we are applying a force. Okay, so this would be force applied. I made it pretty big just because this is a hypothetical situation. It said it was really hard. Okay, force applied. But it's really hard to push. So you're pushing and there is some force backwards. And that force backwards is friction. Okay, and this should be exactly the same size back. Okay, like these should be the same length if you were in math class. Um, it's tough to push because of friction between the box and the floor, so that's the force of friction. It always opposes motion of an object. It's parallel to the surface it's on. So if you can imagine that the bottom of the box here is the surface, friction is always parallel to that. We don't include the surface on here though, so I'm going to get rid of that. There we go. Notice that the normal force and the force due to gravity are still equal. The applied force and the force due to friction are also equal. This would mean that the object has no acceleration. So it is either moving at a constant velocity or not moving at all. Because if it was moving at not moving at all, that's a constant velocity. Okay, so it's because we knew that we're not accelerating this, we're either going to be not moving it at all or at a constant speed. That told us there was no acceleration, which told us that these two were the same size.